In this video, we're going to be looking at signs of trig functions. And we're going to be looking at the circular definitions that we learned in the last lesson. And you will be able to use this reference sheet during your test. First thing that you need to keep in mind is that r is representing the radius of the circles. It's a length, so r is always going to be positive. Problem number 1. If cosine theta is positive, in what quadrants could theta be located? So we know from our circular definitions that cosine theta is defined as x over r, and I know that r is always positive. Since this ratio, x over r, is positive and r is positive, then x has to be positive as well. So you have a positive divided by a positive, which will be a positive answer. So now I just need to look at my quadrant and figure out where are my x values positive. Well, x values are positive in quadrants 1 and 4. So cosine theta is positive in quadrants 1 and 4. Problem 2. If sine theta is positive, in which quadrants could theta be located? Again, I'm going to use my reference sheet to find my circular definition. Sine theta equals y over r. And I know that r is always positive. Since this ratio of y over r is positive and r is positive, then that means y has to be positive. So now I just need to figure out in which quadrants is y positive. Well, my y coordinate is positive in quadrants 1 and 2. So this is something that you really need to keep in mind and be able to recall instantaneously. Cosine is based on your x coordinate, and that is going to be positive when you're in quadrants 1 and 4. Sine is based on your y coordinate, and that is positive in quadrants 1 and 2. And we could go through here and do a similar thing for negatives, or you can tell by looking at your coordinate grid that if cosine is positive in quadrants 1 and 4, then cosine has to be negative in quadrants 2 and 3. Similar thing for sine. Now, problem 3 is a little bit different because we're not given a ratio with r. Right? As we knew in our previous two problems that r was positive, here I'm looking to find out where tan theta is positive, and tan theta is defined as the ratio of y over x. So here I don't know information about y or x. But I do know that when I look at the whole thing together, the whole ratio of y over x, that I have a positive answer. The only way that you can divide two numbers and get a positive answer is if they're both positive or both negative. You can have a positive divided by a positive is positive, a negative divided by a negative is also positive. So x and y are both positive in quadrant 1, and they're both negative in quadrant 3. Problem 4. If tan theta and cosecant theta are both negative, in what quadrants could theta be located? I'm going to start off by filling in what I know. I know that my r value is going to be positive. Now, I'm told in the problem that cosecant theta is negative. So if r over y is negative, that means that y has to be negative. So I'm going to fill in that information. Now tan theta is negative, so y divided by x is negative. That means x has to be positive, because if a negative divided by a positive is negative. So I'm looking at this coordinate xy, and I know that my x coordinate is positive and my y coordinate is negative. That would put me in quadrant 4. For problem number 5, I would like for you to pause the video and see if you can do that on your own, and then come back and check your answer. And there's your answer for problem 5. Problem 6. If sine theta equals -4/5, then determine the quadrants where theta could possibly lie. Sketch the angles in standard position where theta is between 0 and 2 pi. So I know sine theta is y over r. Now I also know that that is equal to negative 4/5. But remember that r is the radius and it's a distance, so it's positive. So that means that that negative really has to go with the 4. So my y-coordinate is negative. So y-coordinates are negative in quadrants 3 and 4. And there's the sketch of my two angles. Problem 7. If tan theta equals 2/5, then determine the quadrants where theta could possibly lie. Sketch the angles in standard position where theta is between 0 and 2 pi. So I know that tan theta is defined as y over x by my circular definitions, and I'm also told in the problem that tan theta is 2/5. Now, that does not necessarily mean that x and y have to be 5 and 2, both being positive. We also could have them both being negative. So I would have negative 2 for y and negative 5 for x. So if I'm looking at the coordinates x, y, I could have the point 2, 5, or I could have the point negative 2, negative 5. So I could have my angle line in quadrant 1 or in quadrant 3, just like we saw in problem 3 earlier. Problem number 8, if cosine theta equals negative 12/13 and theta lies in quadrants 2, then find sine theta and tan theta. Now, the first thing I've done is that I've sketched out my angle in quadrant 2. I've drawn a point to represent the point on my circle, and my point is going to have coordinates negative 12 something. I don't know what that y-coordinate is yet, but I do know that the radius of my circle is 13. So the distance from the origin to the point that I have drawn is 13. Now I know that cosine theta is x over r. I know r is always positive. So if cosine theta is negative, then that means my x has to be negative. So x is equal to negative 12. Still don't know what y is. And r is going to be positive 13. I know from my circular definition that r is defined as the square root of x squared plus y squared. So I'm going to fill in the information that I know. And then I'm going to simplify this negative 12 quantity squared and then solve the equation. Okay, so we've solved this radical equation by squaring both sides. And then when we end up in our last step having to go from y squared to y, I take the square root of both sides and I get y to be positive or negative 5. Okay. Well, y can't be both. So we have to go back and look at the information that we're given in our problem, or look at your sketch that you've done. You know that this point lies in quadrant 2, so we know that our x value is negative and our y value is going to be positive. Okay, so I've got y to be positive 5, and I'm going to go ahead and fill that information in here over on the left side of my screen. So now I know what x, y, and r are equal to. So all of that work just to find x, y, and r, and now I need to finally answer the question, finding sine theta and tan theta. Sine theta is y over r. Y is 5, r is 13, so 5/13 is my answer. Tan theta is defined as y over x, so 5 over negative 12, and that's going to be negative 5/12. Okay, in problem number 9, I don't know right away in which quadrant my angle lies, but I am given enough information that I can figure that out. Sine theta is greater than 0, so sine theta is positive. I know r is always positive, so if this whole ratio is positive, that means y has to be positive. And so I look back at my original problem and I'm told that tan theta is negative 2/5. So if tangent is negative, then I know that my x value has to be negative. So I have this ordered pair x, y. X is negative, y is positive, so I am in quadrant 2. So I know that tan theta is negative 2/5, so that means either the 2 is positive or the 5 is positive, and I've figured out that the denominator here, or my 5, is going to be negative and y is going to be positive. My next step is to figure out what r is. So here's my formula. I'm going to plug in what I know. So r is the square root of 29. I'm asked to find sine theta. Sine theta is y over r. I figured out that y is 2, r is the square root of 29. So I need to rationalize my denominator. I get 2 times the square root of 29 over 29. Problem 10, I'm told that tan theta is 3/4 and theta lies in quadrant 3. Now I know that tan theta is defined as y over x, and I know that tan theta equals 3/4. But that does not necessarily mean that y is 3 and x is 4. This 3/4 is the simplified ratio. Now if I'm in quadrant 3, I actually know that x and y are both negative. So now I can use that information to plug into this formula for r. Now recall that r is the radius, and that's always going to be a positive number, so the square root of 25 here is 5. So now I know all of the numbers that I can fill in my two ratios for sine theta and cosine theta. Sine theta is y over r, so that's going to equal negative 3 over 5. Cosine is going to be negative 4 over 5. Problem 11, if cosine theta equals negative 3/5 and theta lies in quadrant 3, then find sine theta and tan theta. Pause the video and try this one on your own and then come back and check your answer. Filling in what we know that x is going to be negative 3, r is going to be positive 5, and we're going to use this equation to determine y. Solving this equation, we get y to be positive or negative 4, but I know that my point that I'm looking at lies in quadrant 3, so my y coordinate has to be negative. So now I know all three of those crucial numbers to use in my ratios to find sine theta and tan theta. And there is your answer. I would like to say that there's more than one way to do some of these problems. So if you have any questions on any of this, please let me know.